Hello, everyone. Welcome to, once again, another UMH webinar. I think it's number 3. So the last ones were very cool, very successful. Had a lot of fun over there and amazing questions for the community and you. So welcome back. And in this webinar, we will focus this time on how you can retrofit your machines with IO-Link sensors. Maybe in a minute, a bit more to that. But let's start with a quick introduction round. My name is Mateusz. I'm Customer Success Manager at UMH. Before that, I was doing 5 years digital transformation in a big consulting company, and finally can take over a bit more responsibility over here with implementation, which means I'm supporting our customers in piloting up to the scaling. And today, once again, supported by Alex, my co-founder and CEO.
Thank you, Mateusz. So I'm Alex. Perhaps a few already know me, but I actually have a mechanical engineering background and then quite fast sidetracked to IT. So Jeremy, my co-founder and CTO, and I actually building a system integrator prior to UMH, so like 6 years ago roughly, where we primarily focusing on getting data from the shop floor to applications and vice versa. And like one key problem back then, I think even more pronounced than now, was not everybody on the machine vendor side really want to play the game. So they don't want to provide you data because of it costs 5,000, 10,000 per machine, or their company policy doesn't allow them actually to push data out of the machine. And so back then we already used IO-Link to actually fetch some rudimentary data points because we were already working with McKinsey back then. So we need to have fast results. So we could not wait months. So the system machine builder is actually providing us the API. So we want to provide you now a little bit more in-depth tooling and how to actually get the last few machines connected and use IO-Link for that end.
Yeah, thank you, Rich. I think we're going to give you a quick intro on, especially for the new joiners, who we are, what we do, what our vision is. For this, I will just quickly share the screen and then hand over to Alex for a second.
So as an visual anecdote, a few proof points that we actually did what we're now preaching. This was 2019, 2020 timeframe. So we were working in actually different industries. So it was semiconductor, it was metal cutting, so like getting large steel and cut it into smaller steel, or automotive packaging. So we actually did a lot. And a lot of the times it was, for example, in pharmaceutical or semiconductor, actually you're not allowed to change the machine, and some people interpret it actually to going to the interface as a change, or like just putting a cable there as a change. So we took light barriers, for example, to count ibuprofen is coming from the line. So in a pharmaceutical case, we used button bars to actually get super intuitive interaction to the shop floor worker on why the machine is not working. Is he on a break? Is he in maintenance? And this is actually a little bit the origin on where we come from. And yeah, this was how we cracked the nut of non-connectable machines back then. And what is UMH to also a broader picture? This was just one symptom of this distributed systems and data points that you found on the shop floor. So you have data in machines that you sometimes cannot access. You have data in MES systems that you can access. You have data in PLCs and DCS systems and ERP, etc. And you need to consolidate all these different data streams, so the producers of those data, to then fast and easy and effectively build use cases with the data. For a good example is always OE. So you need planning data, so how fast you can produce something, shift data from the ERP. You need data from the control unit, the PLC, to actually see if the machine is producing effectively. You need data from the QMS. So a lot of systems. And with the product, or like with open source tool, which is actually combining more open source products. We don't claim all the fame here for what we're doing, but we are trying to combine those open tools in an intuitive way to then build something like a unified namespace. And in all 2 cents, it's actually 2 things. So first and foremost, the semantic structure. So like increasing quality and context of data so that you can understand where is data coming from, enterprise side, area line, work side, you know the drill, and then also providing a good human readable JSON struct, temperature, 36 units Celsius, temperature sensor from EFM, etc., that you really can understand and drill down into the data later on, part 1. Part 2, perhaps as we're quite technical, is an event-driven architecture for us. So you move away from connecting stuff through a database or connecting stuff through service calls point to point. You move to an event-driven architecture who decouples and technically, not only organizational, the producer and consumer of data points. And if you want to learn more, we have an extensive blog, as you might know. Look at our website, look at the product page. But this is not what the webinar is currently about. We want to go into the trenches and explain a little bit more in depth how you can now crack the last machines who are ugly and hard to connect. Yeah?
Exactly. So just to give you a bit more context. So typically when starting to digital transform, a lot of times you can connect to machines. Yeah, maybe sometimes you have to connect to OPC UA, to Modbus, to Rockwell, and so on. But overall, it's possible. Then, of course, you have different situations where there's a paywall of the machine vendor. You have to pay like 5,000, 10,000 for specific data points for every single machine. Or the PLCs and the machines are way too old to actually connect them. Yeah, so like do it artificially or like limited by hardware. In these both situations, it's very difficult to get a process data, machine states out of it, and really like drive operational excellence.
Like machines, like one customer that we visited 3 weeks ago, he was, we have the new machines, but we have also the machines who are still produced in West Germany, because 30 years, 35 years ago already, Germany was still split in two parts, and in a lot of companies, there is a large gap specialized machinery, which was not updated because it's either not necessary or actually not possible. So you also need to crack those machines and nuts.
Exactly. Yeah. So ideally, you can connect most of them already, but then you will have a red tail of different machines. So like still to collect some at least basic performance data. Yeah. So this is pretty much it. Sensor retrofit is a very common approach and very valuable. But the thing is that a lot of times you have very common challenges of, first of all, which sensors do I actually select? Yeah, it can be the hardware, it can be the specifications of the sensor. Then we're talking about how do I connect these sensors and position them on the shop floor that I can convince people that this is work. Safe. There is the work environment is safe, the hardware is safe. Yes, how is the cable positioned? Am I affecting the compliance, the regulations for the machine, and so on? So these questions are coming up, and then we're finally talking about connecting the data points, collecting and doing the data modeling, and later on also the logics. Yeah, just because you have a light barrier doesn't mean that you immediately know how many accounts are coming through. We also have to identify or like create a logic, depending on the distance that is changing, this was a count, or based on a specific proximity sensors, identify if the machine is running or if there's a very special case of the machine states behind that. So there's a lot of questions, there's a lot of like end-to-end processes. It's not that short. And I think, Alex, you can probably like tell quite a few stories when doing such implementations on the shop floor, and what's the most challenging parts where and why they didn't. I think what would be the most interesting to me, because I also didn't hear the story 100%. Why would you then go for the IO-Link compared to any other standard that you've seen out there?
So I think the main issue back then, as we are like working with a management consultancy, was time. So we had 2, maximum 3 weeks per site to get the rudimentary data out of that, output, availability, or just current working mode of the machine. And we started actually with like classical milliamp sensors back then. So what really did before, there was like in ESP32, like in super small microcontroller based device, which we used and wired then up this 40 to 20 milliamp analog sensors into that. But the problem with that, you could actually only interpret the data as long as you had the machine. So you need to calibrate temperature, you need to calibrate distance, you need to calibrate reflective surfaces for if you like a light barrier. So then was this IO-Link sensor actually plopping up, and it was quite new back then, so 5, 6 years ago. And the cool thing is actually that it has the context already in a human readable form in the body. So it's not providing you like a milliamp hour value, it just provides you a distance, it provides you a temperature, it provides you like actually the stuff that you're searching for. And and this is quite cool for us, and this is why we chose then going from classical analog sensors to IO-Link. And how we actually do that is UMH, and the whole thing is actually IP-based communication, and IO-Link is IO-Link, so you cannot just plug it into a server and expect it to work. So you can just show that shortly.
Yeah, I think then I would just jump over to what we prepared to pretty much go into the depth of it. So our colleague over there is going to change the camera settings. So over here, we have a very simple demo setup of a conveyor belt where we want to show you how you can do this with these specific sensors. Yeah. So you see on the left over here, this is pretty much the conveyor that we'll be moving in a second, and we retrofitted with this AL1350 from IFM Master Gateway 3 sensors to this. So we're talking about here, first of all, the vibration sensor, which is located at the motor here, identifying if the machine is running or not. Then if the machine is not running and this hatch over here is opened, you see a proximity sensor on this side, which is pretty much telling us if the hatch was open. So pretty much a bit more classifying the downtime reason, yeah, giving you a bit more details on that. And to track not only availability, but also a bit of productivity, we have over here a light barrier, which is pretty much set up to identify huge changes in distance, and by that identifying a single piece count. Yeah. So this is pretty much the setup. As you see over here, the sensor is an analog one. We have a digital analog to digital converter over here, and all of them are simply plugged into this device over here.
So what you see here, so this is IO-Link, so like the classical M12 connection cable, like going from the sensor to the master. And in between, there's IO-Link. So like this is a connection that is not just digital or so binary or analog. It's actually like an context-rich communication protocol in between those things. And the magic, or like the making it connectable, is actually happening in here. So like the green cable is actually like an Ethernet cable, also screwed by M12, but it actually makes us easy to connect like via the VM, the server, the edge device to that device. And then this device provides a RESTful API, which then makes it actually easy to fetch, like on a certain frequency, the sensor data from the device. And now technically, it's actually still not human readable. So you have like a bit array coming back. You cannot do that much with it. You need to understand what actually that means. And therefore, the magic of EODD files comes in. This is like, you can imagine it like like a fingerprint of the sensor, which is then publicly available, which describes how you interpret this bit array of data coming in to like a human readable JSON struct of 0, 0, 1, 1, 0, 0, 0, what something means 37 degrees in Celsius from the sensor IV5001, and the switch state is something. So it really helps you then to interpret this IO-Link bit array to a human readable JSON struct. And this is what Bentos is now doing. So this small microservice, a container, we now enriched with the functionality of IO-Link. So not going to only connect to OPC UA, but it can also connect to those masters, and then dynamically checks new information from there, fetches the corresponding IODD file from the registry, so identifies it's a sensor, this is the IODD file, parses that and pushes them back to the UNS, that you can then understand and see actually which data is coming out. Hopefully this helped. If you have questions, let me know. I'll try my best.
Anytime, but also in the same moment, let me just show it to you live. So over here, I brought with me a demo instance of UMH. So this is the classic interface you will see. On the left-hand side, you have the home screen. You see how many tags we already connected, of the latest news, learning articles, and then over here, instance connection data flows, and then the tech browser where our UNS is then located. So instance is already running and in the correct network. The IFM gateway is also in the same network as the instance. So let's just very simply connect to this device. So for this, I select the correct instance. In that case, in this account, we only have one. Should maybe zoom in a little bit to make life easier. I'm going to name it. It's going to be IO-Link master, and then find the right IP address. So this is a local network. So this time 10 IP, and this master gateway is set up only for the 80 port. I think there's also an HTTPS option, but so far I didn't set this up. But yeah, also definitely possible over the 443 port if required. Yeah? So let's click on Save and Deploy, connect to the device. So for people not familiar with it, over here we then create a new container which is dedicated to this specific device, this specific connection. So we can very easily monitor, update, and revert any changes. and then pretty much if this connection fails, all of the other connections.
This is actually also coming from our system integrator background. This is now a two-step process. Firstly, identify the device in the network and actually make sure it's reachable, and then continuously monitor the connection who we then described here, because switches can die, machines can be turned off, power can be turned off, and you're then searching and searching and searching what could be the root cause of the missing data. So we want to provide as much information along the getting data journey as possible, and yeah, making the network connection monitorable is a key part of it, yeah.
So now we know latency is pretty much 0. It's a local network. It's stable, it's green. Let's then go into the protocol converter. So over here, now we extended our list. Now you also see IO-Link over here. You click on it, and then the setup is, I think, even simpler than it used to be for other protocols. So over here, sensor connect. You just have the IP address, port, everything already pre-configured, and then the bit of magic happens then over here. So over here, we create the payload. There's a bit of an exception handling. Some regex over here. Exception handling is then over here. If something with the payload is indicating that it's invalid. So pretty much automating away whatever you can encounter.
And this is expert zone here, so you don't need to change that. It will just work. But if you have like a new edge case or problem, go into that. But just touch if you know what you want to do. And
But overall, you could just save and deploy. For our demo purposes, as I prepared already a bit of logic in the background and also the Grafana dashboard, I'm just gonna input some copied UNS folder structure pretty much. So we're gonna see now the data pointers on UMH, Cologne, Office, and so on, and pretty much save and deploy. So I think we should also talk about firmware on IFM gateways, because I think a lot of people working with these are not super familiar with it. So would you like to start? Because this could potentially lead to one of our small errors that we have. Looks good for now, but let's see.
Yeah, the problem that actually these IFM IO-Link masters might have is actually that they are limited by throughput on the HTTP socket here. So if you don't give it a firmware update, there could be the case that we automatically handle that. It's limited then to 1 Hertz of sensor resolution. But EFM already 3 years ago provided a firmware update for those. Ours are old, so we need to patch them manually. I think the newest ones that you can currently buy are hopefully already on that firmware. No guarantees, because software updates in OT are not always like super promptly. But yeah.
Yeah, so we pretty much updated this firmware, and you see that we are now connecting with these 3 sensors, almost 700 messages per second. I think in the future we will also try to limit this, but for this demo purposes, it's really cool as we have the vibration sensor. Just would like to have tons of data over there to identify the status. Could be also relevant later on for any predictive maintenance use cases and so on that you can think of. But yeah, this pretty much allows us. So we establish a connection, we collecting the data, and now under the tech browser in the unified namespace, you will then see pretty much exactly these data points. So these you can find under raw. So we have our 3 sensors. So sensor number 1 is just a light barrier. Pretty much you see it over here, just flickering a bit. If I move my hand in between, it would immediately switch. And then the second sensor that we have is the vibration sensor. So for this, we're just getting a current. And last but not least is the process value from the proximity sensor. So pretty much if I lift this over here, this will also change and vice versa. That's pretty much it. So if you hit too hard the table, you will also get a bit of reading over there. Here on the second one, there it is pretty much, or maybe it'll just come in a second.
And I will jump to the table.
Yeah, so please be careful during the demo.
But this is actually also like super cool, because like retrofitting externally was always quite either tinkery or like quite hard to do. So either had a choice of going full blow, like provide another Siemens S7 or whatever PLC there to hook up the sensors and then pay like a system integrator a few thousand to get it up and running. Or you go onto the sketchy road, get a Raspberry Pi or Arduino in there and tinker the sensors on your own. And I think this is actually with IO-Link a fair middle ground. Don't get us wrong. So don't fully rely on the system integration schema here to get data into the UNS, but it's always a good last resort measure to get data in there. And then, in our opinion, a good compromise on stability and scalability, but also like ease of use and actually moving fast. So this is how we'd like to see it.
Exactly. So in regards to these IODD files, we are pretty much reading them out automatically as much as possible. There are some cases where the manufacturer does not allow to pretty much cache them or forward them. So in that case, you can also host them yourselves. You will find these details in our documentation on GitHub, but also later on the management console. So what you do is pretty much use an average file server that you have, throw in this XML file you can find in this IODD file, input the device ID, vendor ID, and then pretty much the system itself fetches the file automatically and configures the data points you are collecting. Yeah? So we try to capture some edge cases and make it as simple as possible for you to use it. So we have now the data overall in the tech browser, but of course, just raw vibration distances not giving us a lot, right?
Yeah.
So what we do, just for simplicity purposes, done in Node-RED over here, we are subscribing to these topics. So raw historian 1, 2, 3, as you see over here, and then do some logics. So let's maybe go into the counter, which is the light barrier. So over here, we pretty much just have an if statement over here. If the change of distance is larger than 20 centimeters, we identify this as a count that is pretty much a product that is running through the machine, and then sending a count to our unified namespace with the current timestamp.
That's a good intermediate polling to make it a little bit interactive. Perhaps we can start and get a little bit of feedback on how actually the users see that. So like question number one, actually, did you do that before? Or was there actually never the case where you want to or already did get data through external sensors, or not from the PLC itself? And the follow-up, the obvious question is, did a machine vendor ever was not helpful on providing data points? Was he mostly helpful in providing data points? And just to give a little bit of heartbeat on how relevant you think this is actually for you.
Sure. Yeah. Looking forward to this discussion. So then in that case, while you're clicking, let me just give you an intro to the other data points. So here we're talking about the second, this is pretty much the vibration sensor. With this, we identify if there is too high of amp, we identify this as machine running. So pretty much if there's a lot of vibration, obviously something is happening. If there is, the vibration is lower, pretty much machine is standing still. Yeah? And then just to give a bit more details on what is actually happening, the proximity sensor also is checking if the machine is not running. Then we create a new issue, which is pretty much equipment failure. Just to give a bit more details and be able to identify more easily the root cause of it. Because a lot of times you have a machine line, 20 years old, different station in it, can't collect any data, and it's of course very difficult to identify what exactly the cause was compared to a modern PLC, which gives you the exact error code. But at least knowing where the operator was to solve an issue is already a good indicator which of these machines or machine parts could it be, instead of not just seeing, hey, line is not running and my KPIs are not fulfilled. Yeah,
I think this also perfectly plays into that vision and the promised land that we really want to reach, is that the people running the operations in the factory are having all digital tools available to solve specific business problems and process problems and machine problems. So first things first, I can use the integrated machine data to drill down onto spindle speed, feed rate, whatever. But then there are also sometimes problems and questions that they might have who not already are in the data. So also giving them the possibility to actually have a diagnostic kit, have a permanent sensor attachment, to then go into the problem, put a light barrier on the output, put a capacitive sensor on a door, put a button bar somewhere to specify a specific reason, would help solve a problem. And therefore it should be as easy as possible to implement, and fully aligned with the vision to give good IT tools in the hand of an automation engineer to solve business problems faster.
So in that case, I think let's maybe show the demonstrator itself, so you see a bit of the functionality in action. So if you could maybe change the camera.
Therefore also a quiet round of applause to building this demo thing. But this is...
So there's someone's dream job being paid for building with Lego, right?
Building with Lego,
Yeah. Okay, so as said, overall here you're gonna see the conveyor belt. Let me just turn it on. So it's pretty much running. Maybe, and the pieces are coming, being counted. and a machine that's identified through vibration sensors being running. Yeah. So let me just show you also this in our dashboard over here. So just share back to the screen. So over here, you now see the machine running. Total items will also update in a second. And this is pretty much the machine state that we have over here.
So calculated from what? So it's calculated from?
This is all, everything is calculated from these three sensors that you've seen. Yeah. So we're talking about the state. It's pretty much the vibration sensor.
So this one, yeah.
Yeah, this one over here. You will see also with a bit of delay, then the spike of the vibrations. And then we have the distance sensor over here at the bottom as just some raw data to visualize. And the total items are identified with this light barrier over here that you see them there. Yeah? By these simple measures, you of course can immediately identify the availability, current state, and so on.
Yeah.
And if you just turn it off for a second. So
hopefully it was not as loud for the people.
Yeah, I hope should be fine, right? So there immediately we see unknown stop, machine is not running anymore. We identified that. And then let's lift this little latch over here. And then we should see equipment failure over there. Yeah. So this is pretty much, if this condition is fulfilled, we have this new state, and then this is pretty much the continuous state that we're going to see in that case. Yeah. And now we also see the vibration sensor following up, just a Grafana visualization problem over here. But you see the vibration rising up, so it's very easy to set a threshold, identifying the state, and then pretty much very easy to identify if it's going to be turned off. Yeah. So the same thing goes down if we pretty much close the latch, immediately unknown stop, and then turn on the machine again. There you go, running. Well, at the bottom we then also see the distance sensors, so the flickering of the light barrier, which we then identify the total counts that we have produced.
Very, very cool.
Yeah, that's pretty much it, how you can do it. How many times I also did with Jeremy on the shop floor.
Yeah,
this is very fun. Yeah.
But this was actually like so like background on that, Mateusz, like if he was still in his role at McKinsey, there was also a huge part of this diagnostics. So you like McKinsey, and you really, really want to know how effective like a company is actually producing goods, with all good and bad attached to that. But the ability to actually get in a factory, and I think you did it in 1 hour. Like got in.
Oh yeah, we had some Formula One stops in retrofitting.
Yeah, this was actually crazy. There was, now I need to be very careful to don't say too much, but it was during Corona, and there was like this semiconductor company like on a critical supply chain path on producing a certain good for a certain machine who is super important to solving the coronavirus and saving lives. So Mateusz and Jeremy, the heroes of the time, as in McKinsey and Jeremy duo back then, got in there, had 1 hour because the machine was super critical, cannot stand longer than that, and fetched the data specifically with the sensors, because it was also needs to be, it's a validated machine environment, you cannot get data there, and you don't also have the time to talk to the people because you need to solve problems fast. And this was then the tooling and process of choice to get, is it running? Because when it's not running, because of what? And then you could actually benchmark shifts, you could benchmark processes, you could benchmark setting up equipment procedures of the machines together and then optimize. Yeah. So quite powerful tool.
Yeah, definitely. The nice part of it, Jeremy was already thinking ahead a lot of these things, and it was really we were able to quickly deploy this. So just by having already this workflow, this logic implemented, already have a good selection of sensors, we were able to then just rather think about the logic. So where should we put the sensors, what should it measure, and so on, instead of thinking about this whole integration process, visualizing it, and so on. So it was great to have a product off the shelf pretty much, which was able to deliver so quickly.
Yeah.
Because just being there for 2 hours in total, having 1 hour on the shop floor, and then hearing from the client, hey, are these sensors interfering with our sensors pretty much? So what's their electric field and so on them? So this is the moment where we were sweating bullets, but then it was all okay, luckily to IFM standards, which was saving our butts. And then we did this a couple of times. Also doing this for a metal packaging company in 2 days.
Steel cutting, pharma.
Yeah, 2 production lines, very easily done. It's more about, at some point about creativity, identifying with the people on the ground, what is the process, what is the logic, what do you need from the machine, instead of thinking about this whole integration process, which was super powerful for diagnostics to really identify what is actually going on. and then they define the first patterns. Because if you have a big production line without any data points, it could be anything. Yeah, and then just understanding, hey, there's a pretty much there's a difference in shifts. So people might follow different SOPs. Maybe they need a bit more training on that. There's a difference in cycle times. So just because you see that people are not changing over the machine as quickly, or pretty much. I also remember there was a situation where operator was working on the piece that was, so it was like half automated process. The operator was gluing the pieces together, putting into the machine, and then pretty much waiting. So pretty much like was on off in productivity, while the other operator was pretty much front loading already the next piece and was unable to change and so on. So also identifying such simple best practices was before that pretty much not available, or no one could quantify what the impact could be. So.
And there's also this, also Ricardo wrote in the chat, there's also this business case cost perspective where it's actually quite strong. So if you now need to retrofit every machine with like PLC and sensors and integration costs, you normally are in between 5 to 10K for doing that. And actually having an IO-Link master, which can feed up to 8 sensors, you need 2 sensors per machine. So dividing the cost of the sensor 100 euros and the master cost of 400 euros, actually across the machines can drastically reduce actually the integration cost and time associated with getting it done. So for us, it was always about, okay, what is the easiest way to get to the data, and then working down the solution chain until you have a feasible solution. First, obviously, going through the interfaces, OPC-UA, S7, etc. Then the IO-Link one is actually like an less easy, because also less scalable, because you need to put sensors there, not only a network cable. Last one always to get an PLC modification in there, or like an new PLC additionally for that. But getting options is actually one of the most important things to build a UNS and integrate data. And this is one more that we did years ago, and as is still relevant now, we hope and still believe.
Great to have it finally in the product, and pretty much giving back or giving the community flexibility to do that. I think also important to notice why I personally really like IFM is pretty much it's a huge company with tons of selections when it comes to sensors, and also being able to find sensors which are made for food and beverage and pharmaceuticals. So hot power washable. So I think like IP69 capable sensors, cables, IFM gateways can be a game changer in the specific industries if needed. So this is really cool that you have the option to select such sensors.
And then, if you then want to pay more, like replace this black cable with a white cable, and also this evident cable with white cable, then it's fully pharma compatible and power washable and food safe and X safe and blah. And you can then really, because sometimes it's also about somebody's throwing like resistance at you, like is it X safe, is it compatible, is it certified, etc., etc. And then also having the ability to get them back to best practices and not tinkering, like your own cables, etc., but having off-the-shelf validated components and just plugging them together is additional value driver.
Especially only validating them once if you have to do it. So this can also be a huge benefit there.
And they have an online shop. This was actually the case why we went with them. So in the first place, it was we needed to get sensors, and all the talk and Pepperland folks back then was always contact sales, and we hate that. So as technical people, we want to actually buy everything without ever talking to a person. And they have, I think, a little bit overpriced, but still for us, opportunity cost to cost additional per sensor was well worth it to go then to the online shop. And so I think they also offer like getting started bundles on that if you want to try it on your own.
It's about time, huh? The perfect Christmas gift.
If you want to do something great for your parents, I don't know, send
maybe for your kids as well, depending on what toys they have.
I think they're more interested in the Lego part of it, but
let's see. You have to start small as a child, future engineer.
Fun fact also, I think this machine was built back then. This is not what we built for. We just revived it for that. But originally built, this Lego machine was from a McKinsey partner, I think now 4 or 5 years back, and it's on the weekend. So
interesting. That's also new to me. I just saw people like rebuilding it multiple times.
But this is like a patented UMH property, So don't rebuild it. Okay, just kidding.
Perfect. So I think we have probably some questions. Not sure if Jeremy was able to answer all of them. And additionally, I think we also have the results of the poll, right?
Yeah.
So let's maybe start with that. And then we have plenty of time to go through your questions. I think we also have another poll just out of our curiosity, maybe for the community as well. So let me just want to bring it over here so you can see it easier. So first question, do you currently use external sensors to retrofit machines? And interestingly enough, a lot of people are not using them extensively, but still most people have that already tried out or at least planning it. Yes, I think
80-20, yeah. So
yeah, so very interesting to see that the community is pretty much on the edge of really scaling it or pretty much starting with it. So it's a perfect timing for this webinar. And yeah, pretty much also explains why so many people attended. So this is pretty much a good fit. Very interesting to see. But I'm also surprised that no extensive use. So the question is, of course, like, are extensive users not attending because like not relevant to them? Or is there pretty much very limited amount of extensive users and people that actually feel the pain? Because I can imagine if you don't go the standard route, doing this all of integration process extensively, you definitely have a lot of questions marks. Hey, how can I reduce the time to value on that? Second thing, have you ever faced challenges with the machine vendors? Yes, frequently, occasionally. I think are pretty much all immediately a majority based also from our experience. And then luckily there's at least few people that don't have these issues. Yeah, I'm very jealous.
Those are the people who build their own machine. I'm 100% sure there's always this one machine vendor who is like making problems.
Yeah, true. Yeah, alternatively, of course, the industrial manufacturers that pretty much build their own machines, program their own PLC, only use Rockwell or only Siemens PLCs, and pretty much have everything in their own hands. Very well-educated team on the ground, so they can pretty much pull it off and say, hey, everything is on PCWay, very simple for us.
Or they're super, super large, and then you can just pressure them down.
Also helpful. So in that case, can definitely recommend, if you're talking to machine vendors for data connectivity and so on, reach out to other departments, reach out to other teams, try to collect as many spokespeople for this specific machine type, this specific machine vendor as possible. So we can go as a team of, we have 20 machines of this instead of having, hey, we are asking for a quote for 4 machines, because it's a way different approach and way more powerful if you're asking pretty much for 20 machines, including maybe the procurement team for your company in CC, compared to being a lonely fighter and then waiting for like 6 months to get a few data points as a quote.
And triggering always the quota process,
So it can take a while. Recommend to put it together. It's a bit more effort in the beginning, but can be huge value for the company and create a new best practice how to talk to people and get the transformation for you also going.
We have also 2 questions in the channel. One is actually more like please do that, and the one is actually the online shop link. I think we can put it in the YouTube description or something similar that you can have a look. Perhaps you should ask for a referral fee. We can have an Amazon affiliate link. And then second question, what's a good way to connect with CNC machines, for example, or PCUA, Profinet Modbus, serial sum? So to be honest, CNC machines are always harder, mostly than normal machines, because they are like more proprietary. To CNC machines, we need to talk to the machine vendor. So push for PCUA. There's also the embedded Modbus. I actually not yet have seen. There's Focus that you could use. There's also sometimes Siemens S7 that you could use, but take whatever is standard and your machine vendor provides. Don't talk into anything special, just standard, and don't get into this ping pong of what do you want, what do you have, what do you want, what do you have. Let him provide his standard interface, make a gap analysis, and perhaps retune. There are 2 more questions. Since you read a machine, what's about CE certification? Good question. This is actually like the primary cause on why we started back then because it doesn't touch the CE certification of the machine, because you're not going into the machine, putting new machine into the cabinet, wiring everything up. It's fundamentally external, and therefore doesn't affect CE certification of the machine, and everything in here is already CE certified. So you should not have problems on audits. Good question. Brian, is there secure connection and how you can encrypt the data flows, TLS, etc.? So there is, I think, a way to do it. I'm sure already.
Yes. So there's an option to configure it. HTTPS. So pretty much over 443 port. But so far I did not do it myself. I know that one of our customers is interested in that, just to have another barrier for cybersecurity in their own network. But yeah, technically possible. We would have to pretty much go into the details about it.
But I'm always skeptical about like certificate-based encryption on OT environments, because also you need then to take care of rotation of the certificates every X years, and this is then also like this authentication. How do you distribute actually the key, etc. So yeah, I think you can do it, but perhaps there's also another way to secure your network and the connection between.
Yeah. Don't forget that whatever data you collect, without all of the logic that you have also in the back end, it's not that meaningful. Yeah. So if you have just distances, vibrations, and so on, without the proper context, it's a bit of a lesser issue than really, of course, yeah.
Output, bench name, product name,
exactly,
customer name.
key data. Of course, it is a question, hey, can someone attack this device and pretty much create some troubles and so on. This is a different discussion, but overall, when it comes to data security, it's
but it's also good that you then detach the sensor collection from the actual control mechanisms of the machine. So even if this device could be corrupted or could be attacked, it doesn't affect and now overrides a distance and temperature value and results in like a boiler explosion. It's fully external, so CE certification, checkmark, and also like it's not critical to the production processes, and therefore also from the process perspective, not that critical. Yeah. One more, was there one more? NCD, IO gateway, and sensors. Let me check. NCD, this is LoRaWAN? No. No, didn't check them, but yeah. The more options, the more better. Sensor, gateway. But this, I think, looks like a wireless communication standard. And the problem that we have with that, it's good for collecting temperature, humidity, etc. So I don't just saw the landing page, but if it's like a wireless communication schema, it's often limited the throughput rate and therefore limited actually the use case that you could deploy. So for example, if you want to collect temperature, humidity once a minute, it's perfectly fine. But if you want to calculate based on like a distance of a light barrier, if there's something crossed the light barrier, you need to have like a high resolution of that to make sure that you capture actually the goods that pass the light barrier. So it's always about use cases, and we extensively also work with LoRaWAN, or customers work with LoRaWAN to collect, I would say, humidity and environmental data, always use case specific. But yeah, the more options, the more better. In the petrochemical industry, we often face significantly wear and tear during startup process with certain pumps, specifically hermetic pumps. We see defect rates as high as 90%, largely due to human error, as these devices lack any form of sensor technology. The critical decisions often need to be made within milliseconds or seconds, heavily relying on operator experience, such as open layers, manage pressure, build up, etc., etc. This sounds to me more like a controlling use case. So like controlling actually equipment and valve positions based on sensors attached to that pump. Be specific, this is not for that. So like there are solutions, so happy to drill into that with you together, but this is more for collecting, analyzing process information, output, state, etc. Not for based on the data coming from the sensor, doing actions, triggering action, therefore control sensors, PLCs are used. So going that route and with a PLC is way more reliable, scalable, and also like certifiable. If you want to try software from UMH with virtual machines, how can I find this virtual setup? So you need to provide your virtual machine on your own. So you ask your system administrator for like a VM. You can also download the operating system that you need to provide on top of the VM in the installation flow. Or you can also use a super small IPC or whatever to put it on there. So we don't provide the virtual machine, we just provide the software that you can install on top of the virtual machine. Yeah.
Okay. I personally can recommend if you want to just have a very simple cloud VM.
I mean virtual hardware like CNC machines. Okay, I think I got it wrong. Okay. No, actually, we ship those things. If we like create a clean instance of UMH, we ship 3 simulators to showcase and show the value. It's an S7, no, it's an OBCUA simulator, it's a Modbus simulator, and it's an MQTT simulator.
Exactly. And we just go here over to connections itself.
Yeah.
So you see immediately over here, these are the standard connections you will always see when you set up a new UMH instance.
Yeah.
Exactly. So you can pretty much from the beginning immediately get a feeling for it and see what's possible. So Modbus, MQTT, OBCUA. If you go over here, you then can select OBCUA, save and deploy, and then you pretty much have the simulated data in there. So you have immediately part of the workflow already built in here, so you have a very quick first time to tag, as we call it here, for optimization purposes.
Cool. So it's just there, just click on it, and you can use to show what actually it's all about.
Exactly. Also from last webinar, you can also potentially share that, but you will definitely find it online.
On YouTube.
Yeah, definitely YouTube. Or the webinar number 2, we also had some demo data simulators and demo dashboards for OE monitoring and energy monitoring use case. So you can also freely use this to explore the workflow and also later on show your team what you pretty much created.
Okay. So actually on our side, if you don't have any more questions, put them in now or ask them us later. And the call to action is obvious. If you want to learn more about it, we are happy to also spend one-on-one time with you and discussing potential business issues and how we could help or don't help. Let's see what your problems are. So just go on the website and click the contact us form, and then one of the team members, or actually perhaps also I really love to do that. So if I have the time, I will definitely attend. Double down on your problems and see if we can help, or just nerd talk about whatever we already did and answer some more questions. Yeah,
exactly. Other than that, feel also free to join our Discord channel. There's over 900 people, wild mix of potential users, manufacturers, system integrators, which are working on the topic of the UNS. Happy to help. Not only about how to work with UMH, how to troubleshoot specific things, or how to implement very edgy cases specifically. Just go there, feel free to join, ask questions. It's going to be an interesting time. And welcome to our, warm welcome to our community.
Yeah. Very cool. Perhaps one question I'd still like to ask. There's somebody asking if you're open source. Yes. So if you want to try UMH, it's completely free to try, and also to also scale and use forever. We don't limit you on that. Go on management.umh.app, put on an account, deploy your own system, and have fun. Yeah? So everything what we're currently showing here, you can also do now after the webinar on your own.
Exactly. Just go on the website, sign up. You will land immediately over here on the home screen. Go to instances, add instance, and then just, for me, it's just going through motion. So select the classic stable version. I think we can also maybe spend like a minute on this. And then you will receive here, call command. You can throw into your Linux VM, and then all of our system is being installed from scratch. So
there's also a dedicated video also on the website. Yeah, you can also follow for that. Yeah,
exactly. So we show pretty much everything. So within, like, depending on your hardware you have, 5 to 15 minutes, you have a full Kubernetes node installed with our whole stack, including the simulators, Grafana, Node-RED, Ventos, UMH, and so on. And then everything is available to be managed, controlled, updated, and monitored over the management.umh.app platform.
So learn, try, and apply. Yeah,
very cool. So, in that case, any further questions?
I don't, but there were more, but I think we cannot squeeze them in the last minutes. So perhaps one last one. Is there an option to add my own protocols in the app? There are multiple ones. So Bentos UMH is actually open source, and all the protocols are as a plugin installed there. So if you have a really, really good protocol that you really want to integrate, just create a PR for that. Jeremy will be critical on if it's really, really good and implemented. You can also fork it on your own. But if it's really good and helpful, we will include it also in the open source stack and make it then also available in the management console. You just write and plug in GitHub, Bentos UMH, and then find the template there and get started. Yeah.
Exactly. And then in that, this whole stack infrastructure is also open source. So you can, super free to deploy your own stuff in there, play around, and make it pretty much your own data infrastructure, your own product, to handle all of your specific use cases.
Cool. Okay.
Yeah. I think it was a blast. Yeah, it was fun. Thank you very much for joining again. Also to you, all of you, on Zoom, on YouTube. Hope to see you soon in the next webinar. Please feel free to message us with your questions if you might miss something and so on, or if we miss something. Happy to answer them offline, online, depending on the format you like.
Go into the Discord. And
Yes, definitely go to the Discord. And I think in the next couple of days, we will probably talk about the next webinar. the topics, the dates. So looking forward to
Stay
seeing you
tuned.
there. Exactly.
Christmas special, but
Yeah, I would love to have a webinar with a
with my hat.
yeah, let's see.
We dress up for you. Okay.
Let's see. You're gonna be the Santa. So guys, thank you very much. Take care.
Bye.